Okay, on to problems 3 and 4 for the next exam here. So, question 3 is asking about CAN networking, and it says a micromod CAN node sends the message ID equals OX247. Use the table to answer the following questions. So, first thing we want to do is take that OX247 and put it into binary. And so that's going to be 0010, 0100 for 4, and then 0111 for 7. We're going to take the bottom 7 bits, that's the node ID, and we can just follow this from the table, right? So it says 7-bit node ID here, 4-bit message prefix there. And then the 4-bit message prefix, we leave off, if you wrote out 4 binary digits as you converted from hex, you're just leaving off that first digit every time when you do this. And so this is the message prefix. We're looking at which node sent this message first, so that's going to be 4, 7 in hex, and that's going to give us that is node 4 times 16. 64 plus 7 gives us 71. So node 71 sent that message. What type of COM object is this? We're just looking at that 0100, so 0100, that's RPD 0 or RPD 01. Suppose another node wants to transmit with ID 240 at the same time as the first node. Which message would win that arbitration process? So let's go ahead and take OX240, turn that into binary. That's going to be 0010, 0100, and then 0000. So let's get that 7 bits, 4 bits. And we can see that the message prefixes are the same here, but the node ID for this one is lower than the node ID for that one. So OX240 wins, and it's because it's a lower number node ID, and that means higher priority. Okay, and then for part D, it's really just asking the same question again as part C. So does the winning node win because they have a higher priority message type or because they were a higher priority node? And we would say it is a higher priority node. And really it's just because this has more zeros in it than that one does, and 0 is going to be dominant. So and you could explain lower equals higher, something like that. And so that's it for that question number 3. Really just understanding the CAN message format and then the priority arbitration system. Next up is question number 4. Micromod node number 2 receives a CAN message with ID OX302, which corresponds to an RPDO2 message asking the micromod to set its 4 PWM inputs to desired percentages. You're told that the digital to analog conversion factor from decimal to PWM percentage is 100 over 255, and that's 100% out of 255 maximum value. There are 8 bytes in the message data field given in hex by, and then this hex values. We want to remember that this is 2 bytes of data for each PWM output corresponding to the RPDO2. So we're really just grouping these by 4 hex digits each time. And then it says determine the desired PWM percentage for the first PWM output. And here we could see that the outputs, if we read the PWM out that's associated with RPDO2 in the table, that PWM out says 0 to 3. So this would be 0, 1, 2, 3. So if they're asking for the first PWM output, that's corresponding to 4000. This is in little endian, which means that each byte, and keep in mind that a byte is 2 hex digits, each byte is out of order, or it's reversed order. So if we convert that to little endian, we have OX0040. Convert that to decimal, that gives us 64. And then we do 64 times 100 over 255, and that's going to give us our percentage, which is 25.1% there, and rounding to 25% would be fine in this case. And that's it for that problem. So it's really just applying the formula that you're given, understanding that this is represented in little endian, and reading the format again of the message that we're looking for.